So good afternoon, everybody, and welcome to our special webinar Beyond Strings and how to efficiently use object variables in QF-Test 9. We will talk about variables in QF-Test and what they consist of, but this will be a special webinar for advanced users. So I assume that you all have worked already with variables in QF-Test. You don't need them, but you often use them and often need them. I will assume that you know everything about variable stacks. You know that you can define variables at different places as global variables, as local variables, as system variables on the command line. You can define variables as parameters of a procedure, as fallback parameters on the fallback stack, so for default values. All of this hasn't changed. So the whole concept of variable is the same in QF-Test until version 8 and in QF-Test 9. So everything you know about this, you can keep. You don't have to forget it or change anything. By the way, in the end of the presentation, I will take two examples where we have a little hands-on session. You can participate by getting the preparation files from our GitLab repository. So in the GitLab repository of QFS, I will also send the link via chat to everyone. You can find some materials which you can download if you want in parallel to do the same QF-Test work as I will present. So here also is the link on the first slide if you want to participate in the hands-on session. So variables. What are variables? You all know. Variables are name-value pairs living on a stack. That means it's like on this postcard, there is some name, which is the name of the variable, which you use then when you, for example, use the dollar parentheses or dollar braces notation in your strings. And then you have a value. And in QF-Test 1 to 8, all variables were string pairs. That means if you have a name, you have a string name, and you get a string value back. Normally, this is not a problem because QF-Test does a lot of conversion in the background. So if you, for example, add a number with a script like rc set global into the variable stack, it will be automatically converted into a string. The same is true for a Boolean value or for any object. So QF-Test automatically takes care of converting everything into strings. I can show this. Here we have a good old-fashioned QF-Test 8. If I now, for example, add some value, a number, and I will put this into execute this to put it in the variable stack. And now I inspect the stack here. I will see there's a number and it has the value 23. And I can change here the value to whatever else. And it will still be this number, which I changed because in fact it's a string. And if I now print this number, by the way, today I'm using Groovy scripts, but you can do everything which we are doing here as well in Jython and in JavaScript, so you can use your favorite language. So when I get this as string, I will get my 235.0. I just put a get class and as second line, so we can see this is a string. And if I instead, for example, would use get num or get number, then I would get a double number because it detects, okay, it has some similarity to a double number because it has a dot in it. So it might be a number double. If I force it to be an integer, QFTest will convert it, will say that it can't convert it to an integer because it's not a valid integer. If I remove the .0, then that works fine. And I can also, for example, evaluate as a bool. Then this is false because the intelligence of QFTest detected that it's neither true nor the string yes, nor the value 1, which decays back into the times where Jython has no meaning mention of true and false, but just ones and zeros, etc. And all of these automatic conversation was happening in the background. By the way, if you have any questions, feel free to ask them in the questions or chat panel of our meeting software. I will take a look at it and try to answer them as soon as possible. So what changed now in QFTest 9? Why do we have this special webinar today? Well, you can say in QFTest 9, we blew up a little bit our variable objects. So I'm sorry. So what we extended here is that we assign now a name, not to this postcard anymore, but we assign it, let's say, to a bigger packet. We name this a variable data type, and the variable data type not just carries the string value as before. By the way, we still have the string value, so if you call it toString on it, on this variable data, if you grab it somehow, you get the string value. But we have as well an object. So the object which you place in it, let it be the number, let it be any object you had, will be placed in this variable data packet. And there is a description which is used in run logs and in the variable data view, so in the tables, as a description of the variable. So how does this look like? Let's take what we have here, for example, our script here, and switch to QFTest 9. We execute this here. It still says, okay, I put the number in some variable named number. But if we take a look here at the variables now, we see that it's showing the description, and the description here is integer in braces, so in parentheses. So you know that the type of the object stored in this variable is an integer. And if you double click, you get the string value, which, well, in this case is 23 as well. But let's put some more interesting object there, like a very generic object. And now this number is called object and has this, well, the string value still is kind of weird because it has the hash of the memory on it together with the name. But you can see how the object, so the string value of the variable is derived from the toString method of the object, and the description is also derived from this string value of the variable. If we put some other object here, let's say a pattern. By the way, this is not the default import in Groovy, so I have to add the import. And then we put here some nice pattern, 1, 2, 3 $. Oh, I have to use simple quotes here, otherwise Groovy would ask me to specify some variable after the $sign. So let's put this here, and of course it's pattern.compile. So now I have put a pattern in here. You see the string, or the string of it still is $1, 2, 3 $, the string value. Here it says pattern, but when I now in a second script read this variable, so let's copy this as well from our old QFTest here. And I don't say get bool here, but the new get object, it's get obj. then we will see here it still has the pattern class as the class and returns a pattern object, which then I could, for example, use it for a match or whatever. So this is what was new, and I think this is almost everything. We could now stop here, or I dive a little bit more deeply into it, how we can work with those variables, modify them, etc., etc. So, like I said, we have still the getString, getBool, etc. The special getter methods in our run context. We can, like before, use those variables with the $parentheses or $braces notation, and we have this new rc.getObject method where we can access names or also variables by name or variables stored in a group with those 2 parameter version of getObject. So I already said we have the number here. You see the pattern, and if I now try to modify it, it will say, well, I have to convert this into a string because I don't know how to create a pattern. The pattern is not one of those default values I know. Okay, I can say use string value. If I would put a number here and modify this number in a way that I keep it to be an integer, QFTest is smart enough to detect this and keep it as an integer. So for simple values like numbers, like Boolean values, you can directly modify them. And if it's not possible, QFTest will ask you if it should cancel the modification or convert it to a string. So converting to the string is always the fallback to keep QFTest compatible to those versions before QFTest 9. So we have seen this, the representation. Also, the representation in the debugger variable view is the same with those parentheses and then the number, the name of the class which the object has, and we can edit the variable content as long as it has still this string form or is easy to convert back. Now let's talk about replacements. If I have, for example, a variable, let's say ext, with a value txt, and I assign this, everything is fine. Now, if I assign a new a variable, let's say file name abc, and then dot extension. The question is, what happens with this string? Is it replaced by the extension or not? And as with QFTest 8, let's, if I now print out this variable content, you see it is replaced. And also, if we look at the table, you see that the variable itself still contains those parentheses ext. So during the getString here, we replace the extension and we resolve all the variables which are inside the string. There's the expand parameter to avoid this expansion. This is also not new. We have this already in earlier versions of QFTest. So if we do like this, we will have the parentheses ext written as in this syntactical form as it is stored in the variable. We can also force the expansion with true. So there's no change here as long as we store a string in it. If we now, let's say, use this weird pattern again and say this is not a string, but a pattern. I know it doesn't make much sense to have the end of the line here and then something which is stored in a group afterwards, but well, let's keep it for an example like this. We run this. Now it's stored as a pattern. You can see here. And the expansion still works because the expansion then is done on the string value of the variable. You can also avoid the expansion like before. But if we omit the expansion parameter here, we will see that the default for non-string values is no expansion. And this makes sense because before we all had everything was a string and we were more or less sure that we should expand all the strings. But now we have arbitrary objects which could have arbitrary information in their toString method and print them out. And then by incidence, there would be some variable replacements looking a string inside there, and we don't want to have a problem because QFTest automatically would replace the content here. So this is something new. With strings, it's the same as before. Say setting null here is like leaving it. With other object, the expansion is not automatically, but you have to force it with expand colon true. Another way, interesting thing is how to get those values in scripts. We already have seen we can get a value with get object of the variable by name. We can set, like before, those variables with set local or set global. We could also get a variable from a group in QFTest with this two parameter form where we say the group name first and then the property name. This is the same as for get string and for get int, for get num, get bool, etc. We can also get those from special groups like the special groups QFTest. But here something is interesting. If we call this rc.getStr on QFTest, and then, for example, version dir. I can't use suite dir because this is not saved. I get the path of my QFTest. If I make get object, it looks pretty the same, but when I print out the class of the object returned, I see that it's a file object, so I could directly also call something like exists on it. So the special group QFTest returns where it makes sense now other objects than just strings, while keeping the same string representation as before. And the same is also true for procedures in the standard library QFS QFT, where we also carefully pick those return values where it makes sense and provide them now in a object enriched form, not only as a string. This also worked, for example, for this new special group which was introduced in QFTest 9, which is the decrypt special group. So where you have some encrypted value and you can use it with decrypt to decrypt it and then use it, for example, for setting up a database connection or whatever. But there's also a new form in QFTest. Oh, and yes, of course, you can also set a property by set property, or there's a new synonym for it. It's set group object, but in fact, set group object does the same as set property. It just emphasizes that you can set any value now and not only strings in those groups. And there's a new form which is kind of easier to write sometimes. QFTest 9 provides in the RC, in the run context, pseudo hash maps, obviously the dictionaries for Jython, where you can directly access the variables by specifying their name in this pseudo group named vars. So I could, for example, say now rc.vars.number to access the object in the variable number, and it returns those number. I can also do it the other way around. To store variables here. By the way, this normally is a set local. Only if you execute it without any local context, then it will be set a global variable. And the same is also true with groups. So you can also say, okay, I want to have the QF-test version. So I say rc.groups QF-test, and then I want the version in this dictionary, which returns the version, which is 905.4. Sorry, I'm already in future. And there's also the special form with a dot here, so you can use the dot syntax for the special QF-test group to access the elements here. So this is kind of nice writing, and you can use it in scripts. You can use it in conditions, for example, if you have an if clause, etc. So, and this also works, for example, for decrypt, etc. And you can also assign variables in groups with this writing. So, could assign my group and my data, and assign some value to it, and then it will create the group and the data. And you can then, for example, print the complete group or print all variables which are currently specified in QF-test. Something we have to talk about are default values. You all know that it's possible to use the special group default to specify some value for a non-defined variable at some point. So if I, for example, want to set here some value, and now I use a non-defined variable like new var, normally I would get this unbound variable, so undefined variable exception here. And then I say, okay, I have some default value. I say default. My new variable has the default value bar. And by this, I can execute this without problems. I can also do this in a server script. Like here, I would say get star, then default is the group name, and then new var still doesn't exist. So I define here the colon and then the default value as a string afterwards, and I have my result. So the problem now comes when I want to, for example, specify a number here. This looks fine, but as soon as I test which type is returned, it's of course a string, because we can just specify a string here as name of the property in this special group default. So we had to find some new solution for that. And the new solution is you can specify for the complete RC object that it should return some default values. So you can say RC, and then with default, now I can specify my object, and then I can directly say, let's use new var here. I get the default value, and I test the class name here. I see. Oh, when I do get string, of course, it's always a string. So I have to say get object here. And I see that it returns the integer object, or if I would specify here a Boolean object, then a Boolean would be returned. So by this, I can specify the default value, and I can use here get object, or I can use the new was to new whatever that is, and it still returns the default value and not this totally unknown, unreadable name of a variable here. I can also use it, for example, to say I always want to avoid exceptions like this one for a lot of access or a lot of getters. I can say, for example, with default null, I always want to return null, and put this into a variable name. Let's say rc0, and then I can use rc0 here to get a null object, something like null, and also for other unexistent variables that works. So now I have a nice way of specifying that I want to have the same default value for all those accesses here. Yeah, and for reference, I wrote this on the slide, so you can look it up. Something I want to talk about as well is return value in procedures. If we have a new procedure here, and I want to return some value, I can, for example, use the return step here, and I can now say I want to return again a number, and this now would return the string 4711 like it would do in QF_test8, except if I specify now the explicit object type here and I say I want it to be a number. So like this, if I now do a procedure call, I assign it to some variable, I execute it, you can see that it now returns an integer. And also you say, okay, the number 4711 will be converted to a number, therefore it writes as number here, and then in the end it is an integer. Here as well it says as number. If I would execute it like this, for example, it would be converted to a double, etc. I can also alternatively use a script to return values. So instead of this one, I can also say throw new return exception. This looks a little bit weird. This is a way to return values as well in QF_test8 and before. But what is new is I can specify here now something different than just a string. So when I execute this, it returns 23. And because this is looking a little bit weird, that throwing an exception is required to return a value from a procedure, there is now rc.return value, which in fact does the same, but looks more like a return statement. So it stops executing the procedure at that point and then returns the value with this, which is specified here. If I want to specify as well that my number has a different string representation, I can do this here as well. For this, I have to wrap first the number in a container object and a variable data object. So value. Now I use qf.wrap object to wrap my object. This is the same as before. No. So when I now run this, I say I get an integer, and I can now here specify a second argument the name 20 and then 3, or and have this as a string representation, which leads to this little odd writing. So the description is I have an integer and the value is and now it uses the specified string representation 23. But if I would use this defined value then and say, for example, get integer, I still get the stored integer object, despite having it with a different string. So let's do that first. Execute it for red. Now in red, I have now this integer 23. Let's say print get rc get int red and returns 23. When I say get string, it's returning the text, so the string version. So this is the ways we can specify the return values of a procedure. By the way, the description is also as a third parameter, so you don't even need this parentheses integer to have written in the run log all the time, but you can directly specify which description you want to use for this variable data object. And also I said those conversions with get int, get num, etc. still work, and as presented still work on the object. So if there is a matching object, it returns directly the matching object and does not change it anyhow. If I combine my variables, like for example an integer here or a file object with a string by putting it with the dollar notation inside, then the complete variable will, or the complete result will be a string, of course. Only if the replacement is a total replacement, like in this example here, then the object type is preserved. I could also think about having something like $data0, $data1, and if one of both 0 and 1 is always empty, then the other one will win and the object type of this is preserved. By this, you can hand over objects as in variables within your test script while still having preserving the compatibility to pre-QFTest9 test suites. And there is a special group which is called as, and this special group allows you to convert explicitly data from one type to the other. For example, if you want to have the string 23 always expanded as a variable, as an integer, you can use rc dollar and then in braces as, in curly braces, sorry, as colon int colon 23, and you have an automatic conversion. By the way, we have already seen this. If I write as number here, internally it does the same. I can also, for set variable step, define the result type. For example, I want to have an integer here. Or when I call my procedure, I can also add a parameter here. I can say the parameter here, for example, is true, and this is a Boolean. So it's written as Boolean here, and then if I double click it, you see that internally it uses these special as group to convert at runtime the string true into a true Boolean value. We have already also here the select explicit object type in the pop-up menu, where I could convert this to something else. Most of the time, that's fine, it's working. But I can also, for example, here say write something which is not a valid JSON. So for example, a string without quotes around, and that's fine, it accepts it, but it will then throw an exception during execution. So this is like a static conversion information for the execution of during the tests. So during test execution, it will be converted as specified. And valid conversions are bool number object, which means convert a JSON string into real Java objects, pattern double JSON here to do the other way around. You can use this with the get object or with the with other conversions where you have some object already in the variable specified, for example here, and then you could convert this into a JSON string. But by the way, you can also use JSON.stringify from the JSON module of QF to do something like this. And command line is a nice way to parse command lines as used in the terminal into array lists to have every command in one element of the list. So if I, for example, say I have a command like remove -rf/, this is a often used command on Linux system, and I execute this, and I specify this not as an object but as command line. So this is kind of a special thing which is not in the pop-up menu. It will then create me a list of it. And if I now print this out in the procedure, you will see that I have this as list of parsed elements by spaces. So conversions, if required, are executed either automatically or explicitly with the special group as. When I have this running on, when I'm already running in the system, my test suite, or if I have variables on the global stack, those variables are living. So these are really on the stack. So when I do a conversion here, it doesn't say set explicit type, but it says convert object to. So here I have the difference in between a static type, which is converted during execution, or the immediate conversion. When I select here, for example, I want to have it a Boolean value, then it immediately converts my string, which was something interpretable as Boolean, into a Boolean. Or this one, I want, for example, this to convert it to a double. I say convert to double, and it's converted to a double. I can also select this here. And if I cannot convert it to something, let's say I have the value ABC here, and I want to have it as a JSON object, which is not valid, then it says, okay, I have an error, and I can still fall back and say convert it at runtime. Maybe then it works, which is not true like for this one. But let's say it's not ABC, but I have a variable named ABC here, and I say want to have it converted at runtime. Yes, then ABC, for example, can have a valid JSON value, which is then converted, and it makes sense like that. Okay, but the question is, are there any questions? No, until now not, so everything is clear, or it was too difficult. To get it a little bit more difficult, I want to talk about how those variables are exchanged in between the QF test process and the SUT process. So when I have now an SUT running, for example, I use this widely used program for selling cars, and I want to send some data from an SUT script to store them in a QF test variable. The data has to move from the SUT process to the QF test process. So because in the QF test process, all the variables are stored on the stack. This works fine. So I, for example, let's say in an SUT script. So in my system or application under test, I say set global variable, some text variable, foo bar is my text, and this worked as before. So you can send it, and it is now, as you can see here, stored in the QF test main process in the variable stack as global variable. That worked before, and this still works as long as we can send it to the other process. QF test internally uses RME, so remote method invocation, to send those variables. So the content of the variable has to be serializable, which is a way of like specifying the content of the variable, the type and a recipe to create this object in the other process. This works fine as it is serializable and as long as an QF test has a definition of the class, and in the SUT, the other process has a definition of the class. So that works fine with strings, with wrappers like integers, like Boolean, with pattern, with date. It works with lists and hashes and sets, or maps and sets, as long as the content as well is serializable. So you can send a list of integers, for example. I could specify something like this here and send it to the other side. And now it's here as text. I can also show this, and when I have now a server script, and I say, okay, let me print this content of the text, rc.vars.text, for example, and I clear here so we can see the result easily. And it's a list. For example, I can say, just give me the second, also, which is the third, the number at the position 2, and it just returns this integer, and it still is an integer. We can also send complex objects. For example, if I want to, I have some, let's say, image here. For this, we have a helper class, the image wrapper, rc.qfd.qfs.image wrapper new image wrapper on RC, and now I can say grab image, and now I can specify, for example, let's say the window here with this QF test ID. As a string, and now let's first see what it is. So assign it to a variable, a Groovy variable here. And it says, okay, I have some image rep object with some data in it. And this image rep here is a helper object from QF test, which is serializable and allows to send images, for example, as part of variables now to the other side, to the QF test process. So I can send it to the other side, and here to demonstrate that it's really sent to the QF test process, I can say, let's log this image, which I get via rc.vars.image. And I have here the image. Let's see, it's really stored. So when I change something here and I log the image again, you see it's still the old image, and it's not somehow got live from the SUT by the definition. If we have elements which are not serializable objects, for example, when I get the buffered image of it, buffered image is a standard Java image which is not serializable. it still seems to work. When we take a look at the object here, it says it's a buffered image in car config. So it still knows about the type. It knows that it is a buffered image, but in fact, in the QF test stack, there's only the strings stored here. We don't have any information about the buffered image anymore here in the stack because buffered image is not a serializable class. I can demonstrate this here. When I print this content, so I print image and then the class, it will say it is only a string. If I try to log it, rc.log image, and the log image requires an image representation. So I have to construct the image representation again from the buffered image here. So new image rep, it's the title and then the data, so rc.vars.image. It gives me an error saying the script failed because there is no constructor for constructing an image out of 2 strings. But QF test does not lose the information of the stored object. If I have access it from the same process, like I make a zip script out of it now and execute it, it works. So it returns the buffered image here, and as we can see in the run log, it keeps the image, and we can still work with the object, which is not serializable, as long as we stay in the same process. So I have some additional information to share with you about those object and variables. The first thing is about the decryption. We have already seen that there is a new special group named decrypt, which is used to decrypt values in QF test. I can demonstrate this here. If, for example, let's go here. I set the value to something very secret, like the word secret here. And I can say encrypt this text. And when I execute this now, oh, it says that this value cannot be converted to an integer, which is true. But it says the value star, star, star. So it uses only stars here as description for the value. And also when I look here, the expansion is only stars. Yeah, let's say I don't want any conversion, so I can store it in the variable. Also here, when I say value, I get stars. When I click on it to edit it, I still get the encrypted value. When I combine it with other values, so let's say a new value, and here the value. So I combine it, now it is created a string out of it, and I combine it with value, of course. This is not a decrypted value, but QF test knows that the original value was decrypted and still has this decrypted flag set on the variable data package here. And I always get these stars. Well, except that QF test, of course, needs the value sometime to work with it. So when I now do a get string, which was correct, I get star out of it, and then print the content of the value, I get the secret. So it's more like a little bit of obfuscation. You have to take care on your forward run log that know where there is some code like this used. But you can use the content, assign it to a variable, and then do, for example, some data connection or whatever with it, and nothing is logged. So the logging by default is keeping the protection here. Another thing is the expansion. We already talked about that only strings are expanded, but sometimes it's also interesting not to expand strings at all because they are coming from, for example, from another command or from a file, a text file, and by random there are some symbols in it, some characters which would represent some variable expansion, and they created a lot of headaches before QF-test9. And now it's possible to say an object or a variable data object should not be expanded by default automatically. And we do this in some special procedures in the standard library, for example, for read text from file. And the third thing I want to share is that a rerun from a run log. So if you have a run log and then you click on it and say rerun this test, not always keeps the content of the object, because the content has to be serialized into a string form to be stored in the XML of the run log. And it's not possible for QF-test to always recreate from this string form the original object. So this is really limited to those simple objects like an integer, like a bool, etc. For those it works fine. For the others, you have to take care that you can work as well with a string, because this is the fallback. It always uses them as a fallback, the string value of the object. So if there are no questions until now, I like to go and try something with you with the examples. First thing I want to share is the configuration example. So some people use special procedures like this one, where they have many values. So this is just 3 for the example here, but they have a lot of values and they get them from some external source, like a web API call or like a file, and they want to convert all these information, which is, for example, stored here in a JSON file, into variables which are then part of the procedure. So in this example, we have a skip variable which would skip the complete procedure, and we have some loop which prints some text. And with classic QF-test, so before 9, I would read the data into some variable, like let's say content, from the file, and now I have to prepare from this file data for the procedure call to be split into variables. I've seen customers which do this automatically or automagically, you can say, in some very sophisticated test run listeners, which then, well, for a procedure call, unwrap those data. We will do this here manually. So I insert a new node where I can see, okay, let's get the JSON content with rc.getJSON, and it's content. And now I define local variables for all those elements which I need. So it's frequency and name. And then in the procedure call, I can specify those also local variables, hand them over explicitly. And this is fine, everything works. It prints out 5 times this very important message. It's a special case, but you can see if there are more information here in the configuration and you need to specify all the data, you have to specify it here where it's called. So if there's a new element you want to add in the configuration, we cannot just add it here in the procedure, but we have to add it to all the procedure calls and all the preparation scripts. So this is becomes very difficult to maintain with the time. So now let's use the content object directly. I can say, okay, instead of those, I use here the configuration content. As config, I say, okay, let's use the content. and let's use it as an object from JSON. So I convert it here now from the JSON script. I don't need the script anymore. And here in the condition, I have a Jython condition. This is the default for me. I can directly say, okay, if in the content, no, the config, I named it, has some skip defined, I skip it. And here I can say, okay, this is not evaluated by default because it's just a text field, but with braces, I can enforce a evaluation of a Jython value here, and I can say, okay, let's use here the frequency, and here this is the name, and it still runs. It does the same, but here I don't have any reference to the content of the configuration anymore in my call. So I have just, when I want to add something new, I just change my procedure, and I do not have to change anything, any callers, because they just hand over the configuration from some source where they got it to the procedure. So this is one of the two examples I wanted to share with you. The other one, I said that we can use also object variables for calling external programs. So let's see, I have a very, very simple program here, which just prints out all the arguments. And I have a run program procedure here where I want to print those arguments. So I insert a new test case and call my procedure here. And let's say hello is my argument. And so I have now here the output of this client, which is hello. Let's say I want to add another word, another argument. So I now modify this. I have to add a second argument here. I have to change my calls here to support a second argument. And now I can add here as well a second argument. And this works fine, but well, it takes some time. And let's say, oh, I need a third argument. So what I do is I add a third argument. This third argument, I move my second argument, for example, here to the third argument. I say hello lovely world. When I run this now, I say, okay, I forgot to hand over the third argument, so I add this as well here. And this doesn't scale really well. That's a problem here. One of the problems. The other one is when I just have optional arguments. Let's say the world is not so lovely today, so I leave this out. Then I still would hand over 3 arguments here to the program. You see the second argument before the comma is just empty. To work around this, QFTest has an option in the replay clients menu where you can say you want to ignore empty arguments when starting a client. Now it's just hello world, but let's say we want to specify now an empty argument here, and it's not possible to mix those. You have to decide whether you want to hand over empty arguments or not. I would try something like this. We would just hand over the quotes here as a quote, a string, which is not what I expect. So it should look like here. And the solution to this is to specify the arguments as list. For example, yeah, I insert those as a special as a variable, and I say here these are my args. I say I want, for example, here hello lovely world. I can say, okay, this is a JSON, so I can specify object from JSON. Then I have a list. Let's see. Here I have my array list, hello lovely world. And now I can go back and say, okay, I have all my args now specified in one variable. I throw away all the other thing. Now I already updated that. And I just need one argument here. And it detects that it is a list and adds it as 3 arguments. So I can run this, hello lovely world. I can say I want only 2 arguments. I don't have to change anything anymore in the procedure. And I also can specify an empty argument. And here now it might also be interesting to say, okay, I have it as a command line. This is my text as I have it as a command line, for example, and just keep it as it is here. And now I can specify here my special command line interpretation group as command line, and let this command line convert to a command line. So in fact, you see here, oh, I added a dot in the end, yes. It interprets the 2 quotes as empty parameter, as, for example, your terminal shell will do that. So this is my special second example, and this comes to the end of my presentation. I'm happy that you all stayed with me until here. I know it is a lot of technical and deeply, sometimes also difficult things. We will prepare this as a video so you can take a look at it in the end. And I'm happy to inform you that in end of October, we will have another special webinar about the new web API request features of QFTest, which are coming up with the next version of QFTest, which simplify testing web APIs, for example, RESTful APIs with QFTest. And I will also invite you to fill out some little survey after this special webinar to give us feedback.